Okay, welcome back to Mr. Hassan's Maths channel. I'm now answering question number 7 from the January 2022 Pure Mathematics P2 International A-Level Edexcel exam. And this question is about trigonometry and trig equations. Saying solve for x between minus 90 degrees and 90 degrees the equation 3 sine 2x minus 15 equals cosine 2x minus 15 degrees. Giving you answers to one decimal place. So now, in this question here, we have this equation involving trig ratios. And to solve this, what we want to try and do is to modify it so that you're only involving one trig ratio, which you can then solve. And there are two basic identities that we learn in P2. And I'll write them down here somewhere so it's out of the way. One of them is that the tangent of an angle, so the tangent of the angle A, for example, is equal to the sine of the angle A divided by the cosine of the same angle A. So the tan of an angle is equal to the sine of that same angle divided by the cosine of that same angle. And the other identity, very important, sine squared A plus cosine squared A is equal to 1. So the sine of an angle all squared, the whole thing squared, what this actually means is this. It means the sine of A all squared. That's what it means. It's just written in this form. Plus the cosine of the same angle all squared will always be equal to 1. Okay? So this is these two identities here are very, very important identities. Those are the identities that even identities later on are based on. We're going to learn later on. So now, how do we apply that in this situation? Well, the tan of an angle is equal to the sine of the same angle over the cosine of that same angle. So if we go back to what we have here, what we can say here is if I take our equation, which is this here, so the equation is 3 sine of 2x minus 15 degrees equals cosine of 2x minus 15 degrees. And if I was to divide both sides by cosine of 2x minus 15 degrees, divide both sides by the cosine of this angle here, then what we'll end up with is as follows. You'll have 3 times the sine of 2x minus 15 degrees divided by the cosine of 2x minus 15 degrees. So sine of an angle divided by the cosine of the same angle is equal to, well, this is going to give you 1. Because you divide this by cosine 2x minus 15, you're going to get 1. So now what you end up with here is basically this is the same as the tangent of the same angle. So this gives you 3 times the tangent of that very same angle, 2x minus 15, is equal to 1. I have now reduced this into a form where I only have one trig ratio, and now I should be able to solve this. So what I can do next is I can isolate the tan of the angle together on one side. So the tan of 2x minus 15 equals 1 over 3. All right. Now, one of the very silly misconceptions that some students have is that they think this means tan times 2x minus 15. And so after this, you see some really strange things going on. Tan on its own doesn't mean anything. It has to have an angle with it. And this is the angle. 2x minus 15 degrees is the angle. We have to solve this equation now using the inverse tan in our calculator. However, before we do that, we have to be very careful about the limits. We have the limits of x between negative 90 degrees and 90 degrees as given in the question. Okay, so what we have to do is you have to be very careful not to lose any solutions or not to get any extra solutions by making sure that we modify this x in the middle to make it look exactly the same as this here. So this has to first become 2x, in which case, as this is an inequality, everything else has to follow suit the same way. So you multiply this by 2, these two must also be multiplied by 2. So that becomes minus 180 to 180. And then I've got to have 2x minus 15. So I've got to take away 15 from each of these. So this becomes 165. And if you take away 15 from 180, you get minus 195. Okay, so now that means these are the limits up between which I should find the solutions to this equation. So I'll say 2x minus 15 degrees is equal to the inverse tan of 1 over 3. So I now go to my calculator and I press inverse tan, and I have 1 over 3. Okay, I make sure I'm in degree mode. Now I'm in radian mode here. So if I press equals now, my answer will not be in degrees. So I have to change this to degree mode. So I go to angle units, which is 2, change it to 1 degree. Now I'm in degree mode. So when I press equals, the calculator knows to give me the answer in degrees. So the answer is 18.4349. 18.4349. 4349 goes on like that. That's 2x minus 15 degrees. Now we have to find all the solutions in the range. Okay, now for the tan curve, the calculator gives you the first solution, which is this one over here. I'm going to round in the end to one decimal place. I've just left it like this for now to keep accuracy. Now, I need to find all the other solutions in this range of values, okay, which will give me the solutions, okay, for inverse tan of 1/3. So 18.43 degrees is one of the angles. Now with the tan curve, it's very kind of simple. Basically the tan curve repeats the same shape every 180 degrees. Okay, so you have an asymptote here. So from 0, and this is 90, and then from 90 to 180, okay, 90 to 90, that's 180, and then you have 270. There's another asymptote, 270, and then you have 360 going up to here. So between 0 and 360, that's what it looks like. There's 270 here, that's 180 here. It's not very well drawn in terms of the scale, but that's how it looks like. So this 1/3 is somewhere over here, and our calculator found this angle over here. All right, now there's another angle over here which also shares the same tan ratio, and there's another angle somewhere back here also which also shares the same tan ratio. Okay, so that's 0, that's going to be 0, that's minus 90, and then that's minus 180, and there's some other angles over here. So basically this is one angle which is in our range, so that's in our range, that's fine. The other angle is over here. Now the tan curve repeats every 180 degrees. So the next time where you have an angle which shares the same tan ratio as this is going to be 180 degrees further on from this. So it's going to be 180 plus this angle, which of course you can see is outside of our range. If I add 180 to 18, I'm going to be outside of the range. So that's outside of our range. So I can't go there. But then the other angle over here, which is 180 less than 18. So you're going to have basically 18.4349 minus 180. Okay, so we take the angle we got and we subtract from it 180. Now that gives us minus 161. What was it again? Minus 161.565. Minus 161.565. That's the other angle, and that is within our range. Okay, if I go back another 180, of course, it'll be outside of my range. So these are the two angles inside the range that we need, which solve the equation tan inverse tan x inverse tan of the angle is 1/3. Okay, so 2x minus 15 is equal to 18.4349 and negative 161.565. Now our objective in the end is to find what x equals. So what I have to do is I have to take these two angles, I have to add 15 to them and divide them by 2. So x will be 18.4349 plus 15 divided by 2. And it will also be minus 161.565, okay, plus 15 and divided by 2. So we should get our answers. So I've got this one already in here, so I'll add 15 to this and divide by 2. That gives me negative 73.28. Negative 73.2825 ... And this angle is going to be given by, let me just go back to where I have the angle. This angle here, I have to add 15 and then divide the answer by 2. That gives me 16.717. 16.717 Now, so my final answers to one decimal place are 16.7 degrees and negative 73.3 degrees. So those are the answers for question number 7, part 1. Okay, so that's trig equations for you. I'm now going to go on to part 2. Now, part 2 says solve for between 0 and 2 pi the equation 4 sine squared theta plus 8 cosine theta equals 3, giving you answers to 3 significant figures. So this time we need to be in radian mode. So let's just prepare and get ready for that. So I have to be in radian mode. So now I'm in radian mode. So ready for that. Now, here we have 4 sine squared theta plus 8 cosine theta equals 3. Now, we already discussed the identity sine squared A plus cosine squared of the same angle is equal to 1. So if you take, basically as we mentioned, it's like taking the sine of an angle and squaring it, and taking the cosine of the same angle and squaring it, it will give you 1. Now, what this does not imply is that sine A plus cosine A equals 1. This is not true. This is not equal to 1. Sine A plus cosine A is not equal to 1. That does not follow on from this. All right, and that's where many people make mistakes in this topic, in this particular topic, and these type of questions. Okay, we know that the sine squared of an angle plus the cosine of squared of an angle is equal to 1, but the sine of an angle plus the cosine of an angle is not equal to 1. Okay, so that's something you should get out of your head straight away. All right, it's like saying 3 squared plus 4 squared is 5 squared. We know that's true, but does that mean that 3 plus 4 equals 5? Well, no, of course it doesn't. All right, so that might be true. 9 plus 16 is 25, yes, but that doesn't mean this is true. Okay, you can't just take the square of all of this side by just taking away the squares if they're a sum of different things. So you can't do that, right? So that's something very important for you to realize, that many students make that mistake here. Okay, so and then they go on to do silly things based on that misunderstanding. So basically what we can do here is we want to try to arrange this so that you have everything expressed in terms of just one trig ratio, either sine theta or cosine theta. So you could have sine squared thetas, you could have cosine squared thetas, okay, whichever you want to deal with. All right, now in this case, of course, the one that has a squared with it is the one that you can use the identity with. I can't use this identity with the cosine theta easily because it's not squared. But with the sine squared, I can. So if I look at this and I say, let me rewrite this identity as sine squared A is equal to 1 minus cosine squared A. Right, if I can rewrite it in this form, then I can see that the sine squared theta is the same as 1 minus cosine squared theta. And if I replace sine squared theta with 1 minus cosine squared theta, I have now got an equation with just cosines and cosine squareds in it. So I'll replace the sine squared theta with 1 minus cosine squared theta. So it's 4 times 1 minus cosine squared theta plus 8 cosine theta equals 3. Now I have this kind of equation that looks like a quadratic. I have squares in it, cosine squared and cosine theta. So what I'm going to do is I'm going to say let cosine theta be equal to, say, x. All right, so I'm going to replace cosine theta with x just to make it more familiar. So this is like 4 times 1 minus x squared plus 8 times x equals 3. Now this looks like a quadratic equation which we should know how to solve. So I'm going to expand the bracket first. 4 minus 4x squared plus 8x equals 3. So I'm going to make sure that the x squared terms are on one side and zeros on the other side. So I'll try and keep the x squared terms, all the terms on one side and the zeros on the other side because it's a quadratic equation. So I'm going to use the zero product property. So what I'm going to do is I'm going to make sure that it says 0 on one side. So I'll add 4x squared to both sides, keep the x squared term positive. I will subtract 8x from both sides, so that gets rid of the 8x from here. And I'll subtract 4 from both sides, so I have 3 minus 4, which is negative 1. So now I have to solve this equation. 4x squared minus 8x minus 1 equals 0. Now, I can try to solve this by factorizing, but if you think about it, I'll need to find two numbers that multiply to give me negative 4. So if I think about using my method here, I don't think it looks like it will actually factorize, but you can just check if you want. Two numbers multiplied to give you negative 4x squared. And when you add them, you get negative 8x. Well, I don't think that's possible. For that to be a product, that to be a sum, they have to have different signs. You only got 4 and 1 and 2 and 2 that will work. So there's no way that this will factorize. So we can either complete the square or we can use the quadratic formula. We have to show one of the methods for solving quadratic equations. Don't just use your calculator and put the answer down. All right, you must show a method. So if we use the formula, you have x equals minus b, which is minus 8, which is plus 8, plus or minus the square root of b squared, which is minus 8 all squared, which is 64, minus 4 times a times c. So 4 times 4 times minus 1 over 2 times a, which is 2 times 4. So that should give us our solution. So we can just stick that in our calculator and get our two solutions. So we have here 8. We'll start with the plus, the square root of 64 minus, it's going to be plus because you have minus times minus, 16, divided by 2 times 4, which is 8. So that will give you one solution, which is 2 plus root 5 over 2, 2 plus root 5 over 2, and of course the other one is going to be, I'm guessing, 2 minus root 5 over 2. If you just put a minus here instead, that's going to be 2 minus root 5 over 2. So 2 minus root 5 over 2. Those are the two solutions of x. Okay, so we can say that means that, because remember we said cosine theta equals x, so I know now that cosine theta has these two values, 2 plus root 5 over 2, and also cosine theta has another 2 minus root 5 over 2. Okay, now let's see what they give us. We have to solve between 0 and 2 pi. So 0 and 2 pi. Okay, now let me just make sure there's no equal signs there. Yeah, that's fine. All right, so now what we're going to do here is we're going to find the solution to these. Now, my guess is this is going to be, of course, more than 1 because you're going to have root 5. So this will give us no solution. I'm pretty sure the value of this, one is going to be more than 1. Yeah. So this will have no solution. If I do inverse cosine of the last answer, you can see it's going to be math error because the value of this is more than 1. And the cosine curve does never go above plus 1 or below minus 1. So here you'll have no solution for this particular part. So the only solutions will come from this one. So this is 2 minus root 5. Okay, so let's go back. 2 minus root 5. So I'm going to do inverse cosine of that answer. And that gives us 1.689. So theta equals 1.689. That's one solution. Now for the cosine curve, there are two solutions in this region between 0 and 2 pi. Cosine curve looks like this. So we've just found one of the solutions, which is going to be root 5 is going to be 2. It's going to be like somewhere over here. I'm guessing somewhere over here. All right, so we just found that solution here. Okay, somewhere in this region here. So we need to find the other solution. For the cosine curve, the other solution is always 360 or 2 pi in radians minus the answer, because this answer is 0, is this number, which is 1.689 radians more than 0, and therefore the other solution is 1.689 radians less than 2 pi. So it's 2 pi minus the answer. The calculator always gives you the first solution, and then for the cosine curve, 2 pi or 360 degrees minus the calculator answer will give us the other solution in that range, and those are the only solutions in the range 0 to 360 or 0 to 2 pi. So I'm going to take this answer, I'm going to do 2 pi minus this answer. 2 pi minus the answer, and that gives us 4.594. So you have 2 pi minus 1.689. So the other value for theta, as we just said, was 4.594. Okay, so those are the two solutions in the range. Okay, those are the two solutions in the range, and the range is from 0 to 2 pi, and we know that pi is 3.14, so 2 pi is going to be 6 point something, so you can see we're in the range. All right, so now we want to give our answers as they said. to three significant figures. So I just have to finally round them to 3SF. That's going to be 1.69 radians and 4.59 radians. And those are the answers to that question, which concludes question number 7. Other questions about trig, identities and equations can be found in the playlist that appears over here. Other questions from this particular paper, which is the January 2022 P2 IAL paper, can be found in this playlist over there. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.